Hi everyone. I think I've probably picked just about the worst time to reveal my voice, rather than just having all of those short particle simulation videos that I've been posting over the last month or so, something like that. The reason why is that I'm uh, pretty ill at the moment. I've got quite a cough, so you'll have to forgive me if I need to mute things during this particular video at times. Forgive me, I'm doing this live. Saves me on editing, but at the same time also to try and demonstrate the power of ChatGPT, and we'll see whether we can actually get this working as I'm hoping it would. So I'm going to mute myself now while I cough. And we're back. So here we go. The whole point of this video is to see whether we can actually build our own small, let's not be too ambitious today, particle simulator using Python and ultimately getting ChatGPT to give us the code. There are a few rules to this game. The first is that I will ask ChatGPT the questions and I will copy and paste the code from ChatGPT into VS Code here and have a go at running it. Now, I know that sometimes the code that it gives us may have some small errors in it. Not that often, actually, but things that may not run quite as intended. So I will try and keep any modifications that I make to be small. We'll see whether we can manage to stick with that, and hopefully we'll be able to see how powerful ChatGPT actually is. So come and join me. Let's see whether we can actually make this work. So I think the first question that we need to ask ChatGPT is what the structure of a program should be in Python if we want to simulate particles. So let's give that a go. Oh, oh, what a great start. Let's try reloading the page while it lets me back in. Here we go. More success. There we go. Right. So it's come up with some pretty sensible stuff, and it's actually even going to give us some example code. So let's see if we can manage to copy and paste this. Look, it's already giving us something. This is looking pretty promising. So it's given us some object-oriented language here, written in Python, where we've defined a class here of particle. It's got a position, it's got a velocity, and it's got a mass. And then you can see it's got an update method against it here, where it works out the acceleration, which is what you need to know, determines what the new velocity will be, and then based on that new velocity, also what the new position will be. And that's a pretty standard pattern for what we want to achieve. The next thing is that we've got a simulate. We've got a simulate function here, and we can call that simulate function to go through each of the particles, calculate what the total force is, and then update the positions and the velocities of the particles. Underneath that, we've got a calculate total force function. This is ridiculous. It in fact looks like it's pretty much doing the whole thing. Shall we copy and paste it in and see what actually happens? Here we go. Well, my first glance being, I should say, just a bit of background, that I've been coding in MATLAB for about 14 years, something like that. Python for probably about 4 years, and I've been recently trying to learn C++. And I've been using ChatGPT to help me to learn C++, where even looking at Stack Overflow or searching on Google in general just hasn't given me the answers that I'm looking for. it's curated an answer for me in ChatGPT and actually really helped me get to the bottom of things. So, for example, if it comes back with something that I don't understand, I can ask it a question to clarify the specific bit I don't understand. And it's really helped me with some of the challenges of learning C++, having really had a basis in MATLAB and Python, which I think are far easier languages to learn. Excuse me while I cough. And we're back again. So anyway, just jumping back, copying this in, having experience in Python, things look sensible. Things look pretty reasonable, really. You can see the only thing that I'm noticing is, for example, the position and update property and method. They're colored white. That means that it doesn't realize the IntelliSense type setup here doesn't realize that that's an option, basically, to call upon this particle object. But I think that's just because it doesn't know what a particle is in this function here. But that should be absolutely fine because we know what a particle actually is. So I think we should just be able to hopefully run this. Now the only thing is, what's it going to do? It's going to update it. So you can see if we look down here, I'm going to add, just because it's good practice, I won't go into why right now, but do look it up. So let's see if we run this, what it actually does with our two particles. I think, looking at it, it's just going to run the program over 1,000 steps. There's no print statement here, so we may want to add a print statement. But you can see on line 37 here that actually we've defined, so the particle takes in position, velocity, and mass, and their tuples, so defining the x and the y in each of these, and then a single value here for mass. So we're placing our first particle in position 0, 0 in our coordinate space, giving it a velocity of 1, 0. And then for particle 2, we're positioning it 5 units away in the x-axis and giving it a velocity in the x-axis as well, but in the opposite direction to particle 1. So let's run it and just check that the thing runs. So I'm going to hit F5 like I normally would. Let's just see if we get something sensible. Right. It doesn't like the fact that, well, it says a float object is not subscriptable. So let's have a little look at what's gone wrong there. I'm just going to get my terminal window down there. So, what doesn't it like about this? Total force. It's complaining. So it's force. So calculate force is down here. Ah. For other particles. So why? So, okay, we're sending particle 1 in and particle 2, yes. Because we've got the standard gravitational Newton's equation for gravity here, G_m_m over r squared, or d squared, distance squared in this case. And the force that's coming out is just going to be, yeah, is just a float object, right? Because particle 1.mass isn't a vector or a tuple, neither is particle 2.mass, and the distance isn't either. Now, for other in particle, if other equals particle, yeah. So it's going through each one of those and it's going to update, or it's going to get the total force. And calculate total force, you can see, is calculated in a loop here, going through each of the particles, and then it's calling an update. And the nice thing is the update method just does a plus equals, so it's just continually adding to the velocity and the position for the effect of each particle in the system. So I think that all we need to do is it's got a little bit confused, or has it? Oh man, has it got really confused here? So we have got the force, but we've not got a force vector. That's the issue. Okay, so I'm going to stop this running, and let's just see if we can get it to fix the calculate force part. Okay, so we'll say that calculate force part is or should be outputting a force vector. Okay, so we need to know the direction of the force so we can update both the x and the y coordinates, not a scalar. Can you update this? In fact, let's refer to it as a function so I can be a bit clearer. Can you update this function to give a vector or tuple out? Let's see what it does. Is it going to do it? Excuse the coughing. Still. Ah, it looks like. I think it's done it. Yeah. Right. Let's copy that in. Does that fix it? Please let this be the thing that fixes it. Because feel free to read that. There's so much good information that comes out of ChatGPT, and it seems so willing to provide that information. It's amazing. So here we go. Let's hit F5 and see whether this actually runs. Ah, we're getting there. So, yeah, okay. So we can't divide a tuple by... Ooh, does it think mass is... So let's just try something just a minute. I'm going to say output it as a NumPy array instead. That's all good. And we'll import NumPy just to keep it simple. I'm always a fan of that. Put it as a NumPy array instead. Let's see if we can do this. Okay. Then that should keep things a little bit simpler. Okay. And it's even knows, I think, that we haven't imported NumPy yet. So there you go. It's even given us that little import there, which is great. So we should be able to do the division now nicely and straightforwardly. Okay. Oh, right. Yes. Okay, so we need to calculate. Whoops. Let's not delete the other crucial function. Okay, here we go. See whether we can make this work. Is this still going to fail? Ah. Because force is a tuple? Is that right? So, what am I not noticing here? NumPy array, force is an ND array. Total force is a tuple. So let's just make it. Let's just turn this into a NumPy array. Or no, in fact, let's not do that. Let's ask ChatGPT, see if it can do it for us. From the calculate total force function as total force from the calculate total force function as a NumPy array. And here let's just check. So it's remembered that we've had that conversation about calculate total force. So now hopefully it's going to give us everything that we need. It's all looking really sensible so far. Let's hope that we can actually make this work. Okay, so let's copy and paste our calculate total force. Please let this be the last issue that we have. I suspect it won't be, but it was either going to be really grand or absolutely disastrous. I don't think we're quite there on either side of that yet. Hopefully we can make it a really positive result. Oh, we're getting a little bit further now. So what does it think is an int? Oh, total force is coming back as an int. Why is it doing that? So, force, right. Huh. Okay. Let's just add some point zeros. Oh, I keep doing this. I want to fix it. Let's get ChatGPT to do it. Our Python is complaining that total force is an int. It is giving this error and I need you to fix it. It should be a float. More coughing. It's even apologizing for the oversight. Here we go. Let's see if we can actually get something that works. So it's recognized that it needs to actually put 0.0 to tell NumPy that this is a float and not an integer. That should be all that we need to do to fix that particular problem. So yeah, okay. So there are little bits of problems to fix, but I think you could almost copy and paste the error message that you got and put it straight into ChatGPT and it probably would know how to fix it, right? So let's see if this works. Next error. Oh, it ran. It ran. We got there. It actually ran. But the problem is we can't actually see what it's doing. So we need to get it to actually spit out something useful. So, or maybe we could even just go, let's just go the whole hog. Should we get it to visualize the particles actually moving? So here we go. That ran perfectly. I don't know. It's I always think it's nice to compliment it because it's so helpful. So let's give it a go. That ran perfectly. So we now need to display the particles so we can actually see them moving. What do I need to add to the code to do that? Yeah, okay. Oh, I need... so I'm trying to say that what we actually need to do is to make it show that in real time. This to be updated in real time, preferably at a frame rate of around 60 FPS. Let's see if we can manage to do that. Okay, so it's suggesting some libraries that we could use, and it's suggesting Pygame. So what do we need to do? So it's actually, is it going to rewrite the whole thing? No way. I mean, it's useful for us to see it in the context, right, of what we've already done. Does it look, is it the same thing that we've got so far? Looks pretty sensible. It hasn't remembered to put the NumPy in. But that's fine for now. So all we want to do is actually visualize this. It's just repeating the same code that we've got already. I should have told it specifically to only give me the code that we care about. So obviously it's taking its time a little bit longer here. But hopefully there'll be the grand reveal. Here you go, right? Draw particles method. Yeah, so it's interesting. It's taking the X and the Y. That seems slightly worrying to me, but it's turning it into an int. But I don't know much about Pygame. I've not used it before. So let's add this in and see what we need to do. You finish the code, please. Is it going to start from the beginning? Oh no. Okay, well, while it's busy doing that, let's copy and paste the code in as we've got it and get it down to, so we need to, yeah, so it's created the particles there. So we're going to do this. Let's indent it because of our if name equals main. Excuse me for coughing in your ear. You really don't need to hear that, but let's see if we can make this work. Would have been useful if I actually had Pygame. So bear with me a moment while I get Pygame actually into my environment. I use Conda. Conda doesn't have Pygame, but I think I'll just do a quick cheat. I'm hoping, well, I say a cheat. I try not to do a pip install when I'm using Conda, but let's just get this running, hopefully. So there we go. I think that's just installed Pygame, so it should. All goes to plan. It says it can't be resolved, but let's leave it for now. It should be there because I have installed it. Hopefully it'll behave itself. Did it get to the end? It get to the end. No? Hang on. Yes, there we go. We just needed these extra lines. Oh no, it didn't quite finish it at the bottom. How annoying is that? Can you please just finish the code from the line that starts? Let's give that a go. There you go. Let's see. No, it's going from the beginning. See, this is where it gets a little bit challenging. So you're kind of seeing the limitations of ChatGPT here, right? Is that even though I specifically asked it to finish the code from this particular line, it's trying to be too helpful and actually give us the whole code. Now, the challenge is I'm wondering if I'll manage to actually get it to finish. Will we actually manage for it to get to the bottom? I may need to be very specific and get it to not include any of the other functions and jump straight to these lines. Let's keep going. Let's see if it manages to finish. It just always seems to get to the end because it's just written so much code that it gives up. I really want this to be a success. So, okay, I don't want you to write any of the functions again. Focus on the code from the initialization of Pygame, right? Let's just see. Just want the code from there. Is it going to listen? Okay. It's looking more promising. Yeah. All looking good so far. Now please just finish this code and we should be in a good place. Okay, everything looking sensible in terms of what we've seen already. Yep. Look at that. That's what we needed. That is what we needed. We were just missing those last two lines. Okay, indent that, indent this. What's the likelihood this is going to crash? High likelihood? Let's run it, see what happens. Oh! I think I can see something tiny up in the corner here. Can you see that? Okay, that's not where we need it to be. So, and I'm guessing maybe the issue is with Pygame. I don't know, I've never used Pygame before. But maybe it needs to be an int. Does it need to be an int? I don't know. I'm wondering if it needs to be an int because it's plotting individual pixels, perhaps. So it has to decide whether to turn the particular pixels on or off. I would have thought you could have passed it a float, but let's have a look actually on the draw circle method. We can't. Okay. It's because it doesn't. Yeah, so I'm not sure, but it put the circles in the corner, right? So we need to get ChatGPT to move those into the center because I think the 0, 0 is probably in the top left, like it normally is when you define images. That's normally the kind of 0, 0 position. We don't want things around that point. We want them bang in the center. So I think we need to see if ChatGPT can realize this. So that ran successfully. I'll give it a compliment. Well done. So what we need to do now is say, unfortunately, the particles in the top left of the Pygame window is not satisfactory. Let's put them close to the middle so we can clearly see their motion. How about that? Here we go. Come on. Does it realize that the center needs to be 400, 300 or somewhere around that point? Oh, is it going to write the whole thing again? Come on. I just want it to update that line. Oh no, okay. I think we might be all right. Yes, so it's finding the window center. This is great. It's getting the window size. It's adaptable. It's putting them both in the center of the window, which is fine because they're moving in opposite directions. So let's just see what that does. The only thing I'm going to copy and paste is this. Oh no, I can't do that. Hang on. Set mode window. No, silly me. I need this. Right. Think this will work? Fingers crossed, guys. Oh, come on. Float division by 0 because the distance between the particles is 0. Okay. Crash the program. Looks like that code is good, but it crashed because the initial distance between the particles was 0. Can you fix this? There we go. So what's it actually going to do? Is it going to update the function rather than... or is it actually going to update the initial positions of the particles? Be a bit more robust to put it in the function, wouldn't it? Because then if they're close to one another, or if they're exactly the same... No, I think it's going to... Okay. Looks like it's not. I think it's just going to add a random offset. Oh. Okay. Yeah. I see. There we go. Yep, we know what we need to replace. So it can offset them by anywhere between, because it's using random uniform, minus 50 and 50 pixels. Check that everything else looks sensible. It does. Let's get rid of this and put this here. Right, I just need to make sure that I've got the random. In fact, I bet you it imported it at the beginning, and it did. I'm constantly amazed by what ChatGPT can do. It's ridiculous. Okay, run it. Come on. I don't know, it feels like Pong, the original Pong game, or something like that. It's there's so little going on the screen, but it's actually made this. Don't you think that's ridiculous? That okay, we've had to advise it a little bit, but we haven't really written any code ourselves. We've got ChatGPT to create these moving particles for us. So let's go a little bit further and see if we can get them to move a little bit faster and have more of them. This works perfectly. Can I have 100 particles of different colors? Let's not go too crazy. Can I have 100 particles moving at around, moving with random velocities that have a range that has a maximum that is about 25 times the speed of the current particles. Let's give that a go. Let's see what that does. So they've imported random again. We've already done that, so we know we don't need to worry about doing that. But I'm hoping that the create list of particles will be adjusted a bit. Let's see if this works. Here we go. It's going to give us a for loop. Oh, this is great. Look at this. I do think ChatGPT is probably a better programmer than I am. That's worrying, isn't it? Okay, let's grab this. Pop it in. Yeah. Do we get 100 particles? I'm so hoping. This looks like it should work. I'm not going to inspect it too much. Let's just run it. How can we not be amazed by this? Look at it. This is flipping ridiculous. We have just created a particle simulation using ChatGPT. Now, what's the immediate problem? Before it happens, what can you predict is going to go wrong? I mean, it depends whether you define it as wrong. But let's think about the border. So I think these particles right now are going to just keep flying off into space. It should do. Why won't they? They don't know that they need to bounce off the edge, but I want them to stay within the window. So let's see if we can get ChatGPT to do that. That was fantastic. However, so give it a little bit of encouragement before we actually tell it that it did something a bit wrong, right? So that was fantastic. However, what I need you to do is make sure that the particles bounce off the boundary. Can you do that in the existing framework we have developed so far? Let's see what it does. Okay, so here we go. It says we need to go to the update method here and add a few lines of code. It looks like it's going to do that for us. Seriously, I'm sorry about all this coughing, but there's not a lot I can do. Hopefully you don't mind, because I'm hoping that we're going to get another exciting result. So you can see here it's checking the boundaries now. So it's checking if the position is less than 0 or if it's greater than the window size, and it's doing that in both the X and the Y coordinates. So it looks like that is all we need to do. And you can see what it does is it flips the relevant velocity. So if it's hitting the X, or if it's hitting the limits of the X axis, then it's going to flip the velocity in the X direction. Likewise, for the Y, it's going to flip the velocity in the Y direction. It only flips the velocity in the direction of the axis that it's rebounding off. So let's grab that and place it under here. And let's see if our balls bounce off the edge. Come on, you can do it. Show us it working. It's hard not to have that anticipation, right, of wanting to see that initial result. I think it's this guy here that's going to bounce first, maybe. Oh, no, because he's going diagonally. I think it is. Here we go. Ready for the first sign. Come on. Come on. Oh. Yes. Look at that. That's because the centers of the particles are defined, right, as the place where it's working out where you're rebounding. I'm okay with that for now, but actually it's a small tweak that I think is worth giving a go. I want them to actually bounce when that edge of the circle gets to the edge. But that's a great achievement. Look what it's managed to do. So just a sec, here we go. That was great. But, there's always a but. I want the edges of the circles, or of the particles, to bounce off the boundaries. But that was great, but I want the edges of the particles to bounce off the boundaries rather than their centers. This is just so cool. I don't know, I feel like I've got a new toy here, but it's way more than a toy, right? That, like, what ChatGPT has managed to do is utterly incredible. This is interesting. It's had to, yes, it's got it right. It's just had to add a radius. Of course it has, because it was just defining some sort of other radius. We're going to add that in. It's updating the functions as it needs to. This is so good. And it's including the radius in its calculations now to decide whether it's rebounded off. The calculations are reasonably straightforward. It just needs to it's essentially not just compare the position of the center of mass of each particle, but also now like minus the radius off that, so it can take account of whether it's hit the boundary or not. So you can see, or in this case, I guess it depends where you are, whether you're minusing or plussing it. Right. Update. So we're going to update all of this, but now we've got a radius that we're not taking account of. Where else do I need to update for the new radius parameter? Now it's had to think a little bit about this, because I'm guessing it's had to go back and consider what I've asked it already. I mean, it's been pretty responsive today, so I'm hoping it's not gonna time out. Aha, right, here we go. It's gonna, the init method, right, to accept radius, which we have done. We've done that already. I see, I'm going to give us a numbered list of the places. This is so good. Draw particles. Here we go. Oh, interesting. Particles and window. What's the surface? Is the surface? Where's that? Draw particles. I think let's just call it surface. That's fine. We can leave that as it is. Or in fact, well, no, we can reuse it there because it's just a parameter local to that function. And is it? Yeah, it's going to use the particle radius there, which is fantastic. and then the creating of the particles. So we've got the offset 50. It's remembered the max velocity as well. Oh man, it's just got such a good memory, hasn't it? Let's not overwrite the Windows Center because we do need that. I think this should fix it. I think this is probably going to be the last thing that I do before I stop the video, because let's end on a win rather than me overcomplicating it. But maybe I'll do another video where I get this code and we add collisions between the particles. I think that would be pretty cool as well. But let's, for now, see how these perform. Do we get the bounce? Do we get the bounce off the edge? It should do. I can't see why it won't, given what it's taken account of. Come on, give us the win. I think we're looking somewhere down here for the initial. Oh, no, this one's going a bit faster. Yes, look at it. So let's just marvel at what ChatGPT has managed to achieve today. We started with an aim. I think it was a pretty grand aim, right? To simulate some particles in Python and get ChatGPT to do the work for us. And here we are, watching these particles move around in the space, bouncing off the edges and influencing each other based on the forces of attraction between them. Because that's all part of the code that it's created. This is amazing, absolutely amazing. And I think testament to what ChatGPT can actually achieve. So if you haven't used it yet, please sign up and use it. Although the more people that sign up, I don't know, I feel like the less responsive it's going to get. But actually, they've done a pretty good job, I think, of scaling it, given how much popularity it's had lately. But I think you should check it out, because whatever you're having to do with anything text-based for your job or for your day-to-day life, I'm sure there's something useful that ChatGPT can do for you. And with a final cough, I'll leave you be for now and bid you farewell, and hope that you have a good day and that you learnt something new about what ChatGPT can actually achieve. I feel like I have, and I look forward to exploring some more new things later. Thanks very much.